Welcome back to our lesson practice review, where today we go over our chapter 3 lesson 2 practice. Lesson 3.02 really covers a couple of main things. We're introducing this new type of function called a polynomial function. We are going to be talking about a couple different things about this. Really, the end behavior is the main kind of focus of today's lesson, where it describes what the function approaches as the input gets farther away from zero in each direction. So we can kind of see here, in this one, the beginning part of end behavior is always as x approaches negative infinity. That's like from zero here as x goes to the left. I kind of follow my function here. F of x approaches some value. And so in this one, since it's going down, our y value is decreasing. And so as this continues on, if I were to continue it on forever to the left, I would be continuing going down forever, which is why it gives us this output of negative infinity. Same thing with the other side here, as x approaches positive infinity. So as I move towards the right, what is my y value doing? Well, my y value is going up. And so we say that f of x is approaching infinity. And so there are a couple different specifics that we learned in the lesson here that are kind of covered by this table. So we may kind of come back to this if you need to on the practice, but these different functions show us different end behaviors. The coefficient is also important because the coefficient tells us if we are pointing in a specific direction. Remember, a negative a value kind of reflects it. So you see if we have x cubed, we kind of have this positive function where on the right side here, it is going up. When we have a coefficient of a negative, now our reflection here happens and we now have a decreasing function. As we go to the right, our y value goes down. Same idea on the even exponents. So we see this is x to the power of 4. As we go to the right, since it's a positive function, it's going up. When we have a negative coefficient, it's going down. All right, problems 1 through 2 is using this graph here to the right. It says as x approaches infinity. So if we're starting here, as x approaches infinity, that's to the right here, we are going to follow this along here, and it would just kind of keep going on and on and on and on and on. A of x approaches, well, it's not negative infinity because it's not going down, so I would say that this one here looks like it's going to continue upward and approach infinity. As x approaches negative infinity, so now we start at 0 and we're going to the left, I can see that a of x is going down. So I would say that it is approaching negative infinity. For number 3, select all the functions that could match this graph. So a couple of main things, kind of thinking back on our table from before here, it's not going to be an even exponent because our even exponents, we saw that the end behavior ended up pointing in the same direction. Since we see our end behavior is pointing in opposite directions, we know we're going to have an odd exponent. So not x squared, and then the rest of these are odd. So now what we have to figure out is we don't have any scale, meaning there's no numbers on this graph. So we really just need to figure out like which one for sure would not match it. And in this case here, if we, again, think back on our table that we just looked at, since the right side here is going up, it's a positive function, meaning when we look at the coefficient, it has to be positive. When I look at C here, since this has a negative coefficient, then I know that this is not true. So I would really say any of these 3 here, since they have an odd exponent and a positive coefficient, it could match this graph. For number 4, here's the graph of the function g of x equals negative 3 x to the power of 7. Complete each statement by writing infinity or negative infinity and explain your thinking. So in the first one here, as x approaches negative infinity, I'm looking at the left side because we're approaching negative infinity. I see that my y value is actually going up. So I would say that g of x is approaching infinity because, again, I'm going towards the y value of infinity. As x approaches positive infinity, I'm going to the right here. I'm approaching positive infinity, and I see that my y value is going down, and it looks like it is approaching negative infinity. Again, I kind of explained it as I went here, but we can kind of see as we go to the left, the y value is going up. As we go to the right, the y value is going down. Problems 5 and 6, fill in the blanks so that each function has the given n behavior. So it doesn't give us any stipulations of what numbers we can use here. What we need to focus on is on the left side here, as x approaches negative infinity, as we go to the left, our y value is going down. So we're going to have something that looks like this. As we go towards positive infinity, as x approaches positive infinity to the right, our f of x value is going towards negative infinity, which is also going down. So in this case here, since the n behaviors match, I know that this is going to have a even exponent. So I'm just going to put 6. And the other thing is that since we see that this right side here is pointing down, I'm going to have a negative number as my coefficient. So one example might be f of x equals negative 2x to the power of 6. For number 6, as x goes towards negative infinity, so as we go to the left, f of x goes towards positive infinity. So my left side is going to look like this. As x goes towards positive infinity, or as we go to the right, f of x goes towards negative infinity. So I got something look like this. Since they're going in opposite directions, my exponent is going to be odd. Let's call it 9. Again, I'm just picking a random odd number. And then since my right side here is going down, I am going to have a negative coefficient, so we'll call that negative 5. And so again, just any number works here. Just I know that my coefficient needs to be negative and my exponent needs to be odd. Number 7, using the numbers negative 6 to 6 only once, fill in each blank to create functions that match the graphs. So I'm going to start by kind of going through and seeing where my negatives go, because my negatives are not going to be in the exponent. We don't deal with the negative exponents yet. We're just going to have positive ones. And so really I'm going to look for which ones point down. That's going to tell me which ones are going to have negative coefficients. So I'm pointing down here and I'm pointing down here. So let's call this negative 6 and let's call this negative 5. And the other ones all have to have positive numbers in it. And so in this one here, we see that this one has to be even since the n behaviors are the same. This one has to have an exponent that's odd. This one has to have an exponent that's even. And this one has to have an exponent that's odd. So when I go through this, since I'm looking for an even exponent, we'll call this 2. An odd exponent, we'll call it, we'll just go 3, 4, and 5. So that matches all the n behaviors there. And then the last two numbers here just have to be positive numbers. The only ones I have left are 1 and 6. And so again, it doesn't have to be exactly like this, but the key is looking for which ones have to be negative when we're looking at the coefficients and which exponents have to be even or odd. For our spiral review, sketch a function that has a minimum of 5, negative 5. So a minimum means that we have a lowest value, which means this is my point. It's my lowest value, and so everything needs to be above this afterwards. And so there's lots of different functions that we've talked about, kind of different function families. For example, a square root function might look like this with a minimum at 5, negative 5. Another type of function that we can use is for number 9, has a maximum of 0, 4. So that's a maximum here. We've talked about a lot of quadratics or parabolas, which would give us a shape that looks like this. You could also do absolute value functions, and there's lots of different functions that we've talked about that have maximums and minimums, but these are just 2 examples. That wraps up our 3.02 lesson practice. Wrapping up our talking about n behavior and hoping that we understand our exponents and what the coefficients need to be.